So now let's move on to the, I guess, the three-unit idea, and this idea of parametric coordinates. Now, Cartesian coordinates is what we're used to seeing on the number plane. And as you know, we describe a curve on the Cartesian number plane with one equation, and then the actual point we describe with two numbers, the coordinates. Parametric coordinates is kind of like the reverse of that. And so we can describe the curve by two equations. And so we have one equation for the x value and one equation for the y value. And so then the actual point is described by one number. And then we can sub that into each of the equations to get the coordinates. And that one number is what we call the parameter. So here's our basic curve of our parabola that we've been working with. And as we saw, it was a standard equation for it. We can write it as x squared equals 4ay. That's the Cartesian equation that we're used to seeing. The parametric form, the two equations, the standard ones we use, are x equals 2at, y equals at squared. So they'll be our parametric coordinates. So this point here, the point 2a, they're the Cartesian coordinates. The parameter at that point would simply be 1. That's where t equals 1. Because if we were to sub that into the parametrics, x becomes 2a, y becomes a. And so each individual point could be represented by just a single number or a parameter. So that's its parameter. Over here, minus 4a would be when t equals -2. So any point on our standard parabola, we know will have its coordinates 2at, at squared. A still is the focal length of the actual parabola. And t is just any real number we can sub in. So how do we find the Cartesian equation? So here's one where x is a half t, y equals a quarter t squared. If it is in the standard form, and you're right in what you were saying, it doesn't necessarily mean it's always going to be in that standard form. What we could always do is make t the subject of one of them and substitute it into the other. And that's probably the easiest way of doing it, rather than mucking about. So this one I could rewrite t equals 2x, so y will be a quarter times 2x squared, and the Cartesian equation, there it is. It's just simply our standard y equals x squared for that one. State the coordinates of the focus. Okay, we know A is a quarter, so the focus is simply naught a quarter. What would the parametrics or standard parametrics be for y equals 8x squared? Well, I guess all I need to work out then is what is A, and then I can get it into the form 2at squared. So if x squared is equal to 4ay, in this case A is 1 on 32. And so my parametrics would be a 16th t and 1/32th t squared. So 2at squared. Oh, there we go.